Hi there, I'm Mr. Orr, and we are today looking at section 7.4 in the geometry textbook, Translations and Vectors. Let's talk first about a translation. I've drawn here an initial line segment AB. And let's say I want to slide it. Remember, a translation is a slide. I want to slide it over 5 and up 1. So I take point A and I go over 5, over 1, 2, 3, 4, 5, and up 1. And this is A prime. And I go B, 1, 2, 3, 4, 5, and up 1. And this is B prime. All right? Now, that would be represented as having taken xy and gone to x plus 5, y plus 1. Okay? So I took the x value and added 5. Whatever the x value was here, I added 5. And I took the y value and I added 1. So if this point originally was 2, 4, then the new point, b prime, would have to be 7, 5. All right, because I go out 7, up 5, and I'm here. The second one, I would take this point, which is 4, 6, 4, 7, sorry. That's 4, 7. And the new one is going to be 4 plus 5 is 9, 8. Because I took 4 plus 5 and 7 plus 1. So I get a new point of 9, 8. All right, that's translations. Now, there is another way of expressing a translation, and it is with a vector. So if I said I want to move line segment AB according to vector V, which is, and I write it this way with these kind of squared off looking brackets, 5, comma, 1, that would tell me to move my x values over 5 and my y values up 1. In other words, I move every point over 5 and up 1. And that's a representation of a vector. Now the actual vector itself is, I'm moving those points according to this vector. But if you think about the vector itself and you start at point 0, 0, the vector is out to 5 and up to 1, and that is the vector. And what I'm going to do here is represent the vector with a single, not a full arrow, but half an arrow. That vector has direction and magnitude. It has direction, which is, you can think of it as a little bit north of east. If this out here is straight east, and this up here is north, so its direction is easterly, but it's a little bit north of east. And its magnitude is whatever length this is, this segment. And remember, you're going to find the length of the segment by taking the square root of x squared plus y squared. We'll get to that after a while. I don't want to go too far with that right this moment, because that actually comes back later in the textbook. But in the meantime, know that you can take the component form of a vector, which this is called right here, 5, 1 with the brackets around it. That's the component form of vector V, and that tells you to take a line segment or a triangle or some other figure and move it over 5 up 1. Component form of a vector. Now, there is a problem here that we'll take a quick look at on page 424 in your textbooks, which is a boat traveling a straight path between two islands, A and D. Now they give us some points here, and I'll go ahead and put these on the graph. And just kind of get a sense of how vectors work. A boat, let's see, we have point A, which is at 0, 0, so, and we have point D, so let's mark that point A, and point D is at 8, comma 4.5. So here's 8, 4.5 right here, and that is point D, 8, comma 4.5. All right, now what this says is, when the boat is 3 miles east and 2 miles north of its starting point, so 3 miles east and 2 miles north of its starting point, and we're going to call that point B. and point B is 3, 2. 3 miles east, 2 miles north. At that point, it encounters a storm, and the storm pushes the boat off course to point C, which is 4, 2. So here is point C, 4, 2. Okay, so the boat traveled this way, and then it moved here, blown off course by the storm. And then it says, write the component forms of the two vectors shown. So the first vector, the component form, would be 3, 2. 3, 2. Whoops, didn't mean that kind of bracket, this kind. All right, because it went over 3 up 2, that's its component form. Then it went 1, 0. It went over 1 and up or down 0. All right. Then the question says the boat needs to travel from its current position, point C, to the island at point D, which is where it was originally trying to get to. Find the component form of the vector from C to D. All right, from 4 to 8 is 4, and from 2 to 4.5 is 2.5. So the component form then is going to be 4, 4, 2.5 in order to get from point C to point D. All right, I hope that makes sense. Again, that's example 6 on page 424 in your books. You are going in this section to be working with vectors. Consider, and with translations that are in the other notation form that I showed you a minute ago. For example, consider a translation defined by the coordinate notation xy becomes x plus 12y minus 7. So this is not vector form, this is translation form, and it's xy goes to x plus 12, we said, y minus 7. Y minus 7. All right, and you are to take an initial point that they give you. Let's take 5, 3. And what happens, here, let me write it over here. What happens to the point 5, 3? Well, this tells you to add 12 to the x value and take away 7 from the y value. So 5 plus 12 is 17, and 3 minus 7 is negative 4. So that's what they want you to do with those. Let's see what else you have in here. You'll have a few problems where you do the same kind of thing with vector notation. I think you'll be fine with that. And so what we're going to do is stop there. And when we move on into the next section, 7.5, we will be doing glide reflections and compositions, which is going to mean that we're going to take a combination of slides, flips, and turns and make them take a figure, say a triangle. You're going to slide it, turn it, and flip it, and see where it comes out. All right? I'll be back next time. Thank you.